Welcome to your new Y42 space. This is the screen you'll be greeted with when you first join your newly created space, and from here on out we can start working on our first pipeline. So to provide a bit of context, Y42 follows an ELT paradigm, extract, load and transform, and those first two steps together, namely extract and load, are what we call ingestion. So when we want to do data ingestion, we need to create a source asset for that in Y42. And assets in Y42 follow the asset lifecycle. That is, first we define them, we configure in code what we want the asset to do and what it should look like. Then we version it with Git so that it is fully tracked and reproducible. From there on out we can do a data build. So we execute the code that we wrote and versioned, and that results in a table in our data warehouse. And then finally, when we're happy with the results of this, we can publish our asset. And then we add metadata and make it available to a broader audience. Without much further ado, let's start by creating our first asset. And as a good first practice, the first thing you should do when working on something in Y42 is to create a new branch. So let's call this one ingest Postgres, because we'll be ingesting a Postgres source. And Y42 will take a few moments to create a new source, a new branch for this. There we go, and as you can see here, we're now working in a separate branch and not publishing directly to main. So it might be useful to know that you can always use Command K in Y42, and that will open up this prompt, which can help to find the right commands we want to execute. So let's create a new source. We can just search for a new source. There we go, and we'll be using a connector. So Y42 uses over 500 connectors that we can use to ingest data from a variety of sources. Let's search for Postgres here, and we can choose either the CData or the Airbyte Postgres connector. Let's pick the Airbyte one, and we'll call this one raw space fuel shop, because the dataset we'll be ingesting is shop data from an intergalactic space fuel shop. Let's hit create. There we go. And the first thing we need to define when creating a new source asset is a secret that we can use to authorize with the database. So I need to copy paste these credentials from the Getting Started guide, where you can also find these yourself. So let's call this secret Postgres space fuel shop. Oh, there we go. The host, as I said, I will be copying. The port we can leave on default. The database we'll be connecting to is Y42 demo data. Then the username is public reader. And the password is don't panic without any interpunction. We can set this to standard. We don't need a tunnel. Let's set this to prefer. And there we go, create. That's the first thing of configuration. Then when we hit next, we can skip the second step because the Airbyte connector doesn't need any further config. And now Y42 will take a few minutes to retrieve the schema. So right now it's connecting to the database and seeing what the schema looks like so that we can start ingesting the data in there. And there we go. Y42 has connected to the database and found the tables we want to be loading in. So we've got a payments table, we've got an orders table, and we've got a customers table. Now we can select all three of these because we want to fully import all of them. And from here on out we need to commit and push. And that's how we have now defined the asset and then tracked and versioned it with Git. So let's provide a sensible commit message, ingest shop, order data. And under the hood you'll see what happens. A YAML file is created that contains the configuration for this asset, for this source asset. Let's commit this. Now Y42 is running some pre-configured checks. Compilation is successful, so all good. And if we now go to the lineage view, we can see our assets over here. So these are the default assets that Y42 automatically generates. We can delete those in a bit. And this is the one we just configured. So if we take a look at public payments, you'll see that there's no materialization yet. We have configured the asset, but the data hasn't been loaded into our warehouse yet. And we do that with a data build. So if we go here to the build tool, we can run Y42 build, the command, and that will build all the assets in our data warehouse. We can also use a selector using -s, and then say that we only want to do the space fuel shop. And this will just select this base. Let's use a star here, and then with Command Enter we can execute this. That will trigger an orchestration, and now Y42 is ingesting the 35,000 or so rows that are in this database and writing them to our data warehouse. There we go, everything is now green, and that means that our builds have succeeded. So as you can see, this took just under 2 minutes. And now if we, for example, go to public payments, we can see that 37,000 rows have been ingested. And we can take a quick preview look at the data and see that we've got amounts in here, an ID, etc., etc. Also in Y42 extracted at timestamp. So that's how we build our data. Now to make full use of Y42, we also want to provide maybe some data tests and some metadata, because that provides us with full data documentation. So you may also know this as a data catalog. So let's take a look at the orders database, for example. And the first thing we want to do is we want to make explicit the columns scheme of this table. So here we can hit sync columns. And as you'll see, now the column names are fully loaded in here. And if we go to commit and push, we can see what file has changed under the hood, and that's this YAML file. And here we can see that our columns are now fully documented. So we know in our config what this table should look like. Let's maybe also do this for the other two tables. There we go. And now again, as we can see, this is fully synced under the hood with the YAML file. And we can also take a look at this YAML file in the code editor. So if, for example, you don't like working in the list view or the lineage view, all of these three views are kept in sync. So if you prefer, you can edit the code here directly. Now let's commit and push. Let's call this one meta sync columns. There we go. Let's head back to the list view and head over to orders. Now all of these make sense. We know that these types are correct, but let's also add some column tests. So here we can ensure that the data that we ingest adheres to the definition that we set. So for example, the ID, the order ID, we know that that has to be there. It has to be not null, and it has to be unique. So we can save that. And then, for example, the customer ID, we want to make sure that we know which orders belong to which customer. So this one can't be null. It doesn't have to be unique, of course, because a customer can place multiple orders. And then finally, for the fulfillment method, if we take a look at the data here, then we can see, where is it? Here we go, that there are two values in here. The fulfillment method can either be serviced, or if we scroll a little bit, maybe we can find one. Nope. Let's just click on two values then. There we go. It can be self-service or it can be serviced. So let's also include that, and let's say that the accepted values here can be serviced or self-service. There we go. So that's how we add data tests, and this way we can test at the ingestion level if the data that we ingest into our data warehouse makes sense. And then it can also help to provide some metadata. So for example, the updated add, that's a timestamp, and I know that this is a column in Central European time. So let's say time at which the order was published to the database in CET. And that way, when a business analyst, for example, runs into some timing issues, they can just take a look here and see, oh, this is always in Central European time. And for example, for the other one, the status, this can either be a 0, a 1, or a 2. So 0 is for cancelled, 1 is for declined, when the payment method was declined, and 2 for accepted. And hopefully most of these orders will be 2. Now, and through these metadata features, we can extensively document our data sets and ensure that everyone always knows what they're looking at. Now, let's commit and push this again. Here we go. I'll once again show that Our changes are now reflected in the YAML file, including the descriptions over here. And we'll add column tests for orders and add descriptions. Now, as a matter of principle, it's a good idea to have descriptions for all columns, tests where you need them. You can also include tags here. And this is also interesting. We can add a status here. So, for example, this table will be a draft. We can add experts here. So if something is wrong with the data, people know that they can contact me. And there are a bunch more extensive documentation features here that you can use. I'll leave it as a bit of homework for you to fill this out for the other tables as well.